Hey guys, welcome to the second video in this Flame game development series where we are making Ski Master, a top-down vertical scroller about skiing. So in the last video, I covered the initial project setup for this game, where we used the game widget to hook our Flame game with Flutter widget tree. And in the game class, we just loaded up a sample tile map to verify the whole setup. In this video, we are going to set up the whole UI flow for this game. Basically all the common game menus and the logic to navigate between them. So here is a high-level flowchart for all the game states that we'll be handling. At the very top, we have the main menu. This is the first screen that players will see in the game. In a real project, you might have some splash screens and intro videos before getting to the main menu. But since most of the time main menu is the first functional screen in a game, I've chosen to start with that. From the main menu, players can go to the settings screen to change the in-game options. In our case, this menu will just contain options to turn music and sound effects on or off. From settings, player can only navigate back to the main menu. Then next, to start the game, one will have to navigate to the level selection screen. Here, players will be able to select a level to start the game. Once a level is selected, the level number will be used to advance the game into gameplay state. This is the place where our core game loop will begin. If a player pauses the game from gameplay, they'll see the pause menu with an option to resume the game. If a player successfully completes the level, they'll get to the level complete menu. From here, they can choose to start the next level, in which case we'll just load up the gameplay again with next level number. And finally, if a player fails to complete the level, they'll get to the retry menu, which will allow them to restart the same level again. Also, I haven't shown it here, but we'll also add ways to get back to the main menu from all these gameplay screens. So, if you have ever implemented navigation in Flutter, all this might look somewhat similar to Flutter's navigator and routes. And that is exactly why Flame offers the router component. This component allows easy navigation between routes, where each route can be made up of Flame components or Flutter widgets. If you go to the Flame docs, you'll find this embedded live example for router. This shows how you can navigate between multiple levels and also pause the game. And if you scroll down a bit, you'll see all the multiple types of routes that this router component supports. I highly recommend reading through this section, but just to explain it in short, there are three types: route, overlay route, and value route. The first one should be used when the contents of route are made up of Flame components. Overlay route should be used when the contents are made up of Flutter widgets. If you have used overlay builder map from Flame in the past, you should know that overlay route just allows those overlays to be used with router component. And finally, value route can be used when you want to return a value when the route is popped. Okay, I think that is enough theory about routes. Now let's get back to the project and start implementing them. So in our game class, I'll first comment out the tile related code from onload. We'll move it to the gameplay route later on in this video. Next, I'll create a router component here and store it as a final member in this class. This component needs a string ID for initial route and a map of all the routes with their string IDs. So I'll create one more final member called routes. This will store the mapping between strings and routes. And since I'll be accessing a class member to initialize the router, I'll have to mark it as late. We'll get back to the initial route parameter once we create the main menu route. But first, let's make sure that router gets added as a child of our game in the onload method. Okay, now we can start with the main menu. First, let's create a routes folder inside the game folder. And in here, let's create a file named mainmenu.dart. In this new file, I'll create a stateless widget called mainMenu. To avoid hard coding the string ID for all the routes, I'll store them as static const member in the route itself. And to keep the IDs unique, let's use the class name as ID. So this one will be mainMenu. Now back in router component, we can set the initial route as mainMenu.id. This makes sure that main menu is the first route in the route stack of this component. And for this to actually work, we'll have to add the main menu route to the routes map. So key will be main menu.id and value will be an overlay route that returns the main menu widget. To quickly test this, let's modify the main menu widget to display a center text widget and then run the game. And as you can see, the text is displayed in the game. Now let's start modifying the build method to create a simple menu. I won't go too much into details here, as this is a common Flutter widget creation workflow that you might already be familiar with. And Flutter widget creation is not the focus of this series anyways. Also, all this source code is available on the GitHub repository linked in the description, so feel free to take a look at that. Okay, so my main menu is basically just a column with a text and two button widgets. First button is to start the game and the second one is for settings. One important thing to note here is that I've exposed the onPressed for both these buttons as void callbacks called onPlayPressed and onSettingsPressed through the constructor. This will allow us to set up the handlers of these buttons in our game class, keeping the widget code free from any Flame related code. Now, according to my UI flow design, pressing play should take the player to the level selection screen, which we don't have yet. So let's create that now. I'll create one more file in the route folder and name it levelselection.dart. To save some time, I'll just copy over the code from main menu and just rename the class, constructor, ID and title text to level selection. Back in our game class, we can add an entry for level selection route in the routes map. Next, let's set the onPlayPressed callback of main menu to make it navigate to the level selection route. For that, I'll create a private method called routeById, which takes a string ID as input. Inside this method, I'll just call the pushNamed method on the router. This method looks for the corresponding route for the given ID and pushes it on top of the existing route. Now we can just invoke routeById from onPlayPressed and make it route to level selection. I'll also have to drop the const from main menu here and we'll have to mark the routes map as late as well. Now let's hot reload and try pressing the play button. And yes, now you can see that we are at level selection screen. Okay, I'll again speed up the video here to skip the boring part and just show the final look of this level selection widget. So here is the actual level selection widget. Same as the main menu, but just replaces one button with a grid view and the other one with a back button. The grid view is actually made up of buttons for each of the levels. Similar to main menu, here too I have exposed two callbacks. First one is a value changed of type int, which gets invoked with the level number that was selected from the grid. And the other one is a void callback invoked by the back button. We can't set up the level selection callbacks just yet, but we can make the back button work. For that, I'll create one more private member called popRoute in the game class. This method will invoke the pop method on the router. This method just removes the current active route from the stack. So if we call it when level selection is active, it will go back to the previous route. And that will be main menu in this case. So let's just set pop route as the onBackPressed callback in level selection route. If I save this and do a hot reload, you can see that I can now navigate between main menu and level selection. Cool. So now let's get started with the settings route. Following the same steps, I'll first set up a dummy settings widget. Then I'll add it to the routes map and also set the onSettingsPressed of main menu to navigate it to settings route. I want a back button in settings too, so I'll just copy that from level selection and set it up to pop the current route. Next, instead of these buttons, I want two toggles in settings. One to control the music and the other one to control sound effects. Switch list style is perfect for this. But to make them rebuild correctly when their state is changed, I'll wrap them with a value listenable builder of type boolean. This widget allows you to listen to a value listenable and trigger a rebuild. And to get hold of these value listenables, I'll create two value listenables field that are exposed via the constructor as required parameters. So essentially, the settings widget will listen to these two value listenables to update their corresponding toggles, and also invoke the corresponding value changed callback when a toggle is tapped. Now, to make the settings route work, we need to provide the two listenables in our routes map. And for that, I'll create two value notifiers of Boolean type with their default value as true. One will be music value notifier and the other one will be SFX value notifier. These can be used as listenables because value notifier implements value listenable. But you can see that I'm getting some errors with the route and overlay route types now. This is a bit unfortunate because classes with these names also exist in the Flutter framework. The import that got added for value notifier just opened up those classes to this file, hence the name clash. To get around this, I'll just hide the definitions of route and overlay route coming from Flutter. Now to make these toggles work, we'll have to set the onMusic value changed and onSFX value changed callbacks to correctly update the corresponding value notifiers. As they are notifiers, they'll send an update to the toggle listeners of settings, making the UI rebuild with correct state of the toggle. And yes, you can see that setting screen is now functioning correctly. Okay, so now let's start creating the gameplay route. This one is going to be a bit different as gameplay won't be a widget. Instead, we want it to be a flame component so that we can set up the whole game world as child of this component. So I'll create a gameplay.dart file under routes folder. And in here, let's create the gameplay class extending from component, which is the base class for all flame components. Next, let's override the onload method of this class and bring in the tilemap loading code that we had commented out from the game class. What this does is, whenever the gameplay component is added to the flame component tree, it will wait for the onload to finish before Flame starts rendering and updating the gameplay component. Now, since gameplay is going to be used as a route, we'll need a static string ID for this class as well. Also, in future videos, gameplay will be responsible for loading the correct tile map based on the selected level. So to control which level gameplay will load, I'll add a final integer field called current level. This will be an input to gameplay constructor. Now back in game class, we can use the onLevelSelected callback of level selection route to navigate to a gameplay route. And to do so, I'll create a private method called startLevel, which takes in the level index as input. Inside this method, we can simply push a new replacement route which builds a gameplay component for given level index. And note that here I am using a normal route instead of an overlay route because the contents of this route are made up of Flame component and not Flutter widgets. Also note that unlike the routes we created earlier, this one is not added to the routes map directly. This is because the input level index to gameplay will keep changing at runtime, and so will the contents of gameplay. That is why I've chosen to construct a new gameplay route on the fly here. But to make sure that this dynamically constructed route still gets a constant ID in the routes map, I'll set the optional name parameter in this method to gameplay.id. Okay, so let's set the start level method as the onLevelSelected callback in level selection and reload the game. Now, if I try to click on any of the level buttons on level selection screen, a gameplay route should be pushed on the stack. Okay, so right now it might seem that we have just navigated back to the main menu, but that is not the case. A gameplay route did actually replace the level selection route, but it is just that it is rendered behind the main menu right now. And we can confirm this by setting the background color property of main menu scaffold to transparent. Now this might look a bit confusing because ideally the gameplay route should have been rendered on top of the main menu. But the thing is, all overlay routes are rendered on top of the game widget using a stack widget. And as of now, it is not possible to inject any widget-based routes in between the component-based routes. So to make this work, we'll have to ensure that there are no overlay routes in the stack when gameplay route is active. Simplest way to do that will be to make the router pop the topmost route in start level. This means first the level selection route will be popped, and then push replacement will actually replace the main menu with gameplay. And now you can see selecting a level correctly displays the sample tile map. I'll just quickly increase the destination tile size of this sample map to make it cover the entire screen. Okay, so next let's create a route for the pause menu. This one will be very similar to main menu. It will have three buttons: resume, restart and exit, with their respective on-pressed callbacks exposed as optional named parameters. Now let's add a route for pause menu in the routes map of the game class. Next, to be able to navigate to the pause menu from gameplay, we'll have to write some temporary code in gameplay. First, let's add a void callback called onPausePressed. This will be invoked whenever a player tries to pause the game. For quick testing, let's bind a keyboard button as the pause button. To do that, we'll need to add the keyboard handler mixin to gameplay component. This mixin will allow us to override the onKey event method. This method will be invoked by Flame whenever a key event is registered. So in here, I'll just check if the keys pressed set contains the P key. And if it does, I'll just invoke the onPausePressed callback. Oh, and this callback should be an optional parameter. Now back in our game class, we'll have to add the hasKeyboardHandler components mixin. This will let Flame know that there are some components that are interested in keyboard events and it should track such events. Next, in the start level method, we can hook into the onPausePressed callback to actually pause the game and display the pause menu route. For this, I'll create a private method called pauseGame. In here, I'll call the pushNamed method on router with pauseMenu.id as input. And then I'll call the pauseEngine method from FlameGame to pause the whole engine. Now to test this, I'll navigate to the gameplay route and then press the P key. And as you can see, the pause menu gets displayed here. I'll quickly modify the background color of pause menu so that it becomes translucent and the gameplay is still visible behind it. Next, to unpause the game, we just need to set up the onResumePressed of pause menu in the routes map. For this, I'll create a resumeGame method that just pops the current route and calls resumeEngine, exactly opposite to what pauseGame does. And that is it. Now the resume button should be functioning as expected. Next, to make the onRestartPressed callback work, let's create a restart level method. Now we already have a start level method which can load a level if a level index is provided. We can just call start level from restart level with index as current level. Also, since it already calls router.pop and router.pushReplacement, it will perfectly pop the active pause menu and then replace the existing gameplay with a new one. But the only problem is the current level index is stored inside the gameplay class. So we need to somehow get hold of the active gameplay instance while restarting. Now there are multiple ways to solve this. A simple approach would be to store a reference to gameplay in the game class and keep it up to date whenever a level change happens. But I'd like to show an even better approach that does not require any new class member in the game class. And for this, we'll be using the recently introduced component key APIs from Flame. Basically, all Flame components now have an optional key parameter of type component key. Once you set a key for a component and add it to the component tree, you can use that key to get hold of that component from almost anywhere. So let's go to gameplay class and expose the optional key parameter from its constructor. And back in the start method, I'll set the key to a named component key with input as gameplay.id. Note that this does not need to be the same as the string ID. It just needs to be something unique that can be used while looking up for this component later on. Now that we have a key for gameplay component, we can use it to find the active gameplay instance in restart level. This can be done by calling the findByKeyName method with gameplay.id as input. And since in this case we are 100% sure that component at this key will be of type gameplay, I'll set the generic parameter of this method as gameplay. As findByKeyName can return null if it fails to find the component, we'll have to perform a null check on the returned value. So if it is not null, we can simply call startLevel with gameplay.currentLevel as input. Since this restart will happen when the game is paused, we'll also have to call resumeEngine after reloading the current level. Now let's test this by setting restart level as the onRestart pressed callback in pause menu and hot reload the game. And as you can see, on pressing the restart button, I'm getting an exception saying component key was already registered. Unfortunately, this is a known bug in Flame 1.9.1. But fortunately, this has been already fixed in the main branch of Flame by yours truly. This means the fix will be available in version 1.9.2. If that version is released by the time you are watching this, just upgrade to that version in your pubspec. But for me, I'll have to upgrade the project to depend on the main branch of Flame from GitHub. And to do that, I'll just add the dependency override section in my pubspec and override Flame to point it to GitHub version. Now let's save this and let pubget do its thing. Okay, and before I retest the restart button, I'll quickly add a print statement in onload of gameplay to print out the current level. This will help in identifying if a level is actually reloading or not. Now let's build and test this. First, I'll go to level 2 and you can see that it prints the same in the console. Then I'll pause and resume the level a couple of times to make sure that it does not print anything new in the console. And finally, if I press the restart button, you can see that the console log count increases. This indicates that a new gameplay instance is created and loaded every time we restart the game. Finally, to make the onExit pressed callback work, I'll add a new method called exitToMainMenu. This method will first call resumeGame to pop the pause menu and resume the engine. Then it will call router.pushReplacementName to replace the active gameplay with the main menu route. And that should be all for the pause menu. Now we can resume, restart and exit the gameplay from pause menu. Now let's create a new file for the level complete screen. I'll use the code from pause menu as a starting point for this with some necessary renaming. And now this can be added to the routes map. Next, to be able to navigate to level complete route from gameplay, let's add one more void callback called onLevelComplete in the gameplay class. For now, I'll invoke this when the C key is pressed while the gameplay is active. Now back in startLevel method of game class, we can set this onLevelCompleted. For this, let's create a new method called showLevelCompletedMenu. In here, we'll just push the level completed route using router.pushName. I'll set this showLevelCompleted menu as the onLevelCompleted callback and hot reload the game. And if I press the C key while gameplay is active, we'll get the level complete menu. Next, let's change the text of first two buttons on the screen to make them next and retry buttons. Their callbacks will also have to be renamed to onNextPressed and onRetryPressed. Now the retry and exit buttons won't need any code change. They should work with the same setup as the pause menu. But for the next button, we'll have to add one more method in game class. I'll name this one as startNextLevel and set it as the onNextPressed callback in level complete route. Code in this method will be almost same as restart level. It will just increase the level index by 1 while calling start level. And it won't need to call the resume engine here, since the game won't be in pause state when level completes. If I hot reload and test this in the game, you can see that clicking next actually changes the current level printed in the console. This means the next button is working as expected. And all this works nicely with pause, resume and restart too. Now let's take a look at the final menu that we need for this game. And that is the retry menu or game over menu. This will be displayed when a player fails to complete a level. I'll create a new file called retrymenu.dart for this. The code for this will be similar to level complete menu minus the next button. So after renaming things to retry menu, I'll remove all the code contributing to the next button. Now we can add an entry for retry menu in the routes map. To trigger a route change to retry menu from gameplay, I'll again add a new void callback called onGameOver. And to invoke this, let's use the O key. Back in the start level method, we can hook onto the onGameOver callback using a method called showRetryMenu. This method will just push the retry menu route on top of the gameplay. Okay, and now I can hot reload the game and test this. So while the gameplay is active, I can launch the game over route by pressing the O key and then press retry to restart the level. And it seems to be working just fine. So yeah, that is all for this video. It turned out to be a bit longer than I had imagined. But at least now we have the overall game flow working correctly. And from the next video, we can actually start focusing on the fun gameplay stuff. As for now, make sure to hit the like button if you enjoyed or learned something new in this video. Consider subscribing to the channel to show your support, and I'll see you in the next one.